Hello to all, this is Lata from IT department. I am going to handle you entity relationship model in database technology. First let us see what are the learning objective of this topic. This topic we are going to discuss about entities, relationship and as well as aggregation between the entity and relationship. So what is, before going to see that entire thing, let us see what is data model. Data model is nothing but is a diagram that displays a set of tables and relationship between them. So we are going to see how to relate the database design. Okay, before going to design database design, data model is very, very important in order to identify the entity and the relationship between the entities, as well as we are going to identify the attributes between the among the relationships in the table. This is a sample ER diagram. In this diagram, we will be seeing about different categories of table and associated between the table. And here, what is entity relationship diagram? This diagram is a data modeling technique used in software engineering to produce a conceptual data model of an information system. Here in the ARD diagram, we are going to illustrate about the logical structure of the data model or databases. So we can say ER diagram is nothing but blueprint of the data model. So before going to install anything, before going to implement anything, let us see in a paper how to design our data model, how to integrate all the data models together in order to implement our data model in an effective way. See, first we have to identify entities, as well as after identifying entities we have to make the relationship between the entities by means of association between the entities. At last we are going to make a identify the attributes. So these are the three things we are going to learn in this session in a deeper manner. Next, so here in the major activity of entity is identifying entities, attributes and relationship by means of constructing a entity relationship diagram. Here the entity is nothing but in DBT technique we are going to say entity as a table, and attributes nothing but a column of the table, as well as relationship nothing but a line between the tables. So in the whatever we have seen the previous diagram, here the box represent the entity, as well as the association between the entities represent the line, as well as the each attributes in the table represent the column. We are representing in the column in your table. Next, so how to find attributes, how to find entities and how to find association between the attributes. These things we are going to discuss in deeper manner in the coming sessions. So what is entity? Entity is nothing but a real-time world. It can be a people, it can be a place or objects or events, or it always capable to store information. So normally it can be of two categories, tangible or intangible. Tangible in the sense a customer or product, that's real world entities are tangible, and intangible in the sense order or accounting receivable, like that basic objects are called as intangible. Normally we can looking for the singular noun for representing the entities. Next, so this is a sample diagram that shows the entity table. The entity table have three instances the entity table have three columns: student ID, last name and first name, and each row is called instance of the entity, we can call it as entity instance. Next, how to find attributes. So each entity will have some set of attributes to represent the entity values in a clear manner. So the attributes are data objects that either identify or describe the entities. That is nothing but property of an entity. In other words, it is a descriptor whose values are associated with the individual entities of a specific entity type. Next one, how to find relationship. So there can be a relationship between the different entities available in your database data model. So we have to make a relationship between the data model or by means of entities. It can be of one-to-one relationship or one-to-many relationship or many-to-one relationship. So that is the things done by the developer, or we can say the implementer. Next one is cardinality. The cardinality is nothing but number of occurrences in one entity which are associated with the number of occurrences in the other entity. There are basically three types of entity cardinalities, or we can say degree of relationship. One is one-to-one, one-to-many and many-to-n. Next one, identifier. So identifiers describes attributes that uniquely identify entity instance. So it always primary key in RDBMS, and we can say it is a composite identifiers or identifiers that consist of two or more attributes or nothing but composite identifiers. So identifiers normally underlined by the line. So this is a simple representation of entity and attributes. Here in this entity table, in this entity diagram, student is an entity and all the student ID, first name, last name, date of birth and major department, all those coming under attributes, and whichever underlining is nothing but primary key of that student entity, that is nothing but student ID. And basically we have three types of cardinality: one-to-one relationship, that is a representation of the diagram given there in the presentation, and one-to-m relationship and m-to-n relationship. And this is a symbol which represents the relationship between the entities. And this is a sample entity model. Here the department, project are all coming under entities, and the department and have only one attributes, that is customer ID, and the relationship between the department and project is one to many. Here the relationship always varies, and this one is one department we have associated with the many project. That is the thing we have to understand from the diagram. And the project we have the attribute called project ID. And this is data model by Peterson notation. Here this is another way to represent data model. Here we have each data model, we have one-to-one relationship, one-to-n relationship, as well as we have some set of attributes associated with that thing represented by this diagram. Next one. So what we have discussed so far is basic business rules, business 1, business 2 rule. These are some business rules we used to follow for representing our entity diagram. Next. The attributes describe detailed information about entity. For example, we have taken an entity employee. So what are the employees attributes? Employee name, address, phone extension, date of hiring, job skill code, salary. And each attribute will be of different categories. So if we have the employee name, normally a person may have unique name or composite name, so that's why employee name. And address, the address can be of composite in nature, that means in address consists of street number, street name, as well as the pin code, postal ID, like that attributes always consist of many values. And phone extension will have unique value, and date of hiring and job skill code and salary, each are numerical type. There are different classes of attributes. That one is simple attribute, composite attribute, derived attributes, singular attributes and multiple attributes. So once we have to identify the type of attribute based on the value it possesses. For example, suppose if you take the attribute name as age, it is always unique attribute. Here the age, simple attributes, it can't be divided. That is simple attribute, the basic one, or we can call it can't be divided into two or more. For example, if you take name, a person may have a single name, or some areas the person may have double names, first name, last name, like that. So it can be, we can call it as a composite names, or we can call it as composite attributes. And derived attribute means, say another example for a derived attribute is age. From the age we are able to identify, derived attribute example is date of birth. From the date of birth we can able to derive the attribute age. So we can call it as a derived attributes. And some attributes it may have only possess one value, that is called single value attribute. For example, gender. A person can be either male or female, that is a single value attributes. And some attribute may possess multiple values, that is called multivalent attributes. For example, a person may have more than one phone number. For example, a person may have 2 or 3 phone numbers. So that is all, that is coming under multivalent attributes. So as we discussed already, a simple attributes cannot be subdivided. For example, age, gender, matter status and all subdivided, not to be subdivided. And composite attributes nothing but further subdivided into yield attributes and other attributes. For example, address. If you take address, it consists of street, city, state and zip. And phone number may have your area code, exchange number. And derivable attribute, that means it's not physically stored within the database, but it can derive the value from the existing attribute. For example, date of birth. From the date of birth, the person can able to derive the another attributes called age. And next one is single value attribute, that means it can have only one atomic value. For example, a person can have only one social security number. Or another simple example is our student database will have a register number. Every student will have a register number or roll number, it's always unique one. So it can't be subdivided, it can't be it can't possess multiple values. So with that type of category of values are called as single valued attribute. Multi-valued attributes can have many values, as we discussed already. Phone number, a person may have 2 or 3 phone numbers. That means a single phone number will attribute can able to store more number of phone numbers. And then another example exists, movie database. Here the movie database entity name is movie star, and the attributes are SS colon. It always comes under single valued attribute, and cell phone number it's coming under multi-valued attributes, and name it's a composite attribute. For example, Harrison Ford, first name and last name, and address also composite attributes because it consists of values like 123, that is a street number, main street, street name, and some other places values. And gender always it is of type simple attribute. It takes the value female, and age. Age always coming under relative attributes type because from the database we are able to derive the age 24. And this is a procedure for ERD. It always relatively simple representation of complex real world data structures. Data model always an iterative process. It is always complete 100% error free model, but it is not possible, and its only optimized model is possible. Thank you.